Hey everybody, how are we doing? I'm going to send out a note right here and say copy video y'all. We'll say we are doing office hours. So let's say office hours live right after class. After class, I go live on YouTube, public stream. You can ask questions about assignments, and we can work on them together. Click here. Okay. Is anyone in the chat? Bueller? Anybody in the chat? Say hi in the chat if you're in the chat. Had a little snack. Oh, I need to put more drinks in my office. Last semester I had soda. Don't put soda in your office. I'm talking to myself. Bad idea. I drank all the soda. Because I had soda. I said, don't put soda in your office. But with this, we're just hanging out for a second. We'll see if anyone joins in. I might do an assignment on my own. Oh, I didn't send out the link. We'll see if anyone joins in. We also throw bonus during office hours. And I got the office hour video up right now. Got the thing there. Look at what's going on in the world of Reddit. What does Reddit say is happening? So I get my news. Reddit, UTK Reddit. All the things going on. It's interesting what you get on popular Reddit. What in the world? It's craziness. So many things. My starting assignment. So many things going on. What's going on there? So many things. So many things. So many things. So many things. Well, I might do an assignment here in a second. Anyone in the chat yet? Mubot's in the chat. Let's see how many people Mubot says is watching. How many people does Mubot say is watching? If you're here, feel free to say hi. I might do first canvas content. I could do that. And say to people, we did the first canvas content. Let's see. Okay. Let's do it. If you join in at any time, just say hi and we can do some work. So, got here 5, 4, 3. Canvas content number. Is it 2? It might be 2 for some people. Let's say canvas content, chapter 1 and chapter 2. So, with the canvas contents, the thing I've started to realize about the world is you could just ChatGPT them. ChatGPT can kind of give you right answers. It kind of can't sometimes. Because there's specific things about this class or the way we do things. It knows a general idea. It knows a consensus of ideas. But what I want you to do is as we do a Canvas content, I want you to take notes on it. Canvas content is the #1 way to know what the test looks like. So while you're doing Canvas content, write down the questions and write down the answers and think about, what am I learning? What is the point of this question? This first one right here deals with data. This is what data looks like. This is a spreadsheet of data. We have here the what's, and this is what Mike Pearson sometimes talks about. The what's are going to be what variables did we collect on? Now notice the question doesn't even ask this, but we should know these concepts. That the what's are what did we collect on? The who are each of the rows. So when you see who, think of the rows in the data. When you see what's, think of the columns in the data. So the columns represent the variables. The variables can be different types of variables. Good to see you, Paige. Let's see what Paige got a good question here. This is an identifier. Paige says, for the data analytics assignment, it is allowed to be 2 pages in order. Yes. Yep. If there's an issue with grading, Paige, let me know. Just threw you some points in the chat for just being here. I'm going over the different types of variables like identifier, which is a special case, categorical variable, cannot, will not repeat. team is going to be a categorical nominal variable. Categorical nominal means that it is groups, and it is groups that do not have inherent order to them. So you can see right here, categorical nominal. So there's no inherent order to it, like you wouldn't say Australia. There's no order to it. Position is also categorical nominal. It's a group. Club is also categorical nominal. And although these were collected in a bit of a discrete way as whole numbers, you're welcome, Paige. Feel free to ask more questions, and we're doing the Canvas content right here, just answering some questions. And the last two right here are quantitative. They were collected in kind of a discrete way because they don't have decimals. So you can make arguments that they are discrete, or at least they are displayed as discrete numbers. So when you have a quantitative number, it can be discrete as in whole numbers, or it can be continuous. And technically these could be done, it can be argued either which way for this variable, but it is quantitative. And so quantitative variables can kind of be said, they can be discrete, like how many pets you own, 0, 1, or 2. Continuous, how many pizzas did you eat? I ate half the pizza. So you can say I ate half, where it can have decimals, 0.5 pizza. So just within quantitative, there are these ideas, and within categorical, there are these ideas. So identifiers are a special case categorical variable, which will not repeat. You can't have the same player ID. So player ID is an identifier. And it says right here, what type of variable is chocolate rating? Now, once again, we got to think about the who's, the what's, and then we have to think about the variable types. Don't just answer the question, know what the data is showing you. This is where you try to review the concepts, understand what's going on right here. Who was collected? It looks like the who's were the companies. And it looks like this will not repeat. So this is an identifier. And then what was collected? Things like company names is a what. Average chocolate rating. Well, think about this. If you can do math on it, actual real math, it is a quantitative variable. So chocolate rating is a quantity of like, this one was rated 3.38 at that chocolatery, and this one was rated 3.25. So you can look at that and compare. This is a quantity of percent of cacao. So you can do math on it and say the second one, not even going to try to pronounce all these. The second one has 2% more percent cacao. That's how you know it's a quantity of percent of cacao in, which is the beans that make the chocolate, I believe. And last but not least, we have, I could do it as blue right here, because identifiers are special case categoricals, so we could say it's a categorical variable, but it's an identifier. We should also note, don't just leave out it's an identifier. Company location is going to be categorical nominal, because there's really no order, and they can repeat. In this one, they actually do repeat, which is a really easy way to say it's not an identifier, because you would know because it has repeated, it can't be an identifier. But, and I guess you could say, what if two companies have the same name? I'd say, well, that's a lawsuit right there. Theoretically, we shouldn't see companies with the same names. And then if you get something like that in data sets, they'll usually do like a -2, like indicating this one came second or something. You couldn't have, as the identifier, a repeat. You'd have to some way .2, -2, or especially with movies, if movies have the same name, they'll do like 2024 after the movie. Like if you look like The Thing came out in like 1982, and then there's like The Thing 2002. So they put the number after Ghostbusters 2019 or something like that. They put a thing after it to identify which Ghostbusters it is. So you're like Ghostbusters 2019, even though it's called Ghostbusters. The variable average chocolate rating is what kind of variable? It is a quantity of average chocolate rating. All data needs what for us to understand? Well, we see a lot of this in our notes. When you look at the notes right here, you can see this data does not have it, and this data does, because all data needs context right up there. All data. I thought I was going to squish that. Look at that. All data needs context. Context is what gives it meaning, what gives it understanding. Think about this. Is swinging a bat good or bad? Well, you might have swung a bat and hit a home run. You might have swung a bat and broke a window at your house by accident. So the context matters. The idea of swinging the bat, how fast it goes, I guess data also on what it hits. I mean, maybe you're trying to demolish a house. Are office hours recorded to? Yes, 100% Elizabeth. There's so much context. Context is in and of itself data, and then all data needs it. So you collect the context of the data with it. Parameters are going to be the truth about the world you want to understand. We did a little note on this today. I take a lot of notes during lecture. We did a cake example during lecture with these 5 terms. So we talked about this cake and your mom making this cake, and you want to know what the town thinks of it. You go to Potlucks, you bring it to Potlucks. So you would take a sample of this cake, and that sample of the cake is going to be a subset, a slice of the cake, subsetting it, and it's going to allow you to estimate how good that cake is. So the parameter is what everyone thinks of the cake. Like you want to understand what everybody thinks of this cake that your mom makes. It'd be the true rating if we got very statistical talk on it. It'd be the true rating of everyone in the town because the population is everyone in the town. Your mom wants to know what everyone in the town thinks because she makes the cakes for potlucks. You really couldn't get a census, which is everyone in the town has to try the cake. Maybe you could. A lot of cakes. Then is it good samples, biased samples? So that would be a census when you collect data on everyone in the population to understand the parameter of interest. And the words that go together here, I want to point this out. You could group them in two ways. Statistics make samples. So you can't say like a population statistic. We don't say that. We'd say a population parameter. So you would want to say a population parameter, which means population and parameter go together. But there's also the sense that samples and populations go together because they're the groups. And also statistics and parameters go together because statistics estimate parameters. The parameter is the truth, like what does everyone in the town think of the cake? The statistic is what do the people who've tried the cake think of it? The samples go together with population because the sample is the subset of the population. So just depending on the way you think about it, you can kind of compare them. So I like to say sample statistics give estimates of population parameters. But you don't want to say like a sample parameter or a sample population. That stuff doesn't make sense. A Pareto chart, so this gets into chapter 2, which we haven't covered yet. But a Pareto chart is a special case bar chart. So Pareto chart, we like to say put them in order, is a special case bar chart. The IQR stands for the interquartile range. So when you think about what the IQR is, it stands for interquartile range. And a lot of people know what the range is. If you think about the range, if you were to go here and have a bunch of data and put your data into quarters, what do we mean by quarters? It means 25% of the data is in each quarter. Maybe you collect data on 80 people. With collecting data on 80 people, this would be a sample size equal to 20 in Q1, a sample size from Q0 to Q1, and a sample size of 20 here. It might not always be perfect. This one does work out perfect right here. It's going to be 20, 20. I don't know, I'm writing something different than 20. If you were to break it into four groups, like sample size, n means sample size right there. That is what lowercase n means. So you would have 20 people in each quarter of the data. You could say, I'm in the top quarter of the class. You're in the top 20 students. I'm in the bottom quarter of the class. I'm in the bottom 20 students. And you could have grades for these students. This student right here could have made a 20, and this student all the way up here could have made 100 on the test. So when you think about the idea of a range, just the range, we know the idea of max minus min. And it's kind of easy to understand that it's big number minus small number. When we think about the interquarters are going to be right here. So what you'll actually look at is the grade of the person here. And if anyone says, I'll throw some big points in the chat. If anyone figures out what the interquartile range is, excuse me, and the person here. So what would be the interquartile range? The range of the data is 80. So the range of the data goes from 20 to 100. That's a range of 80. What would be the interquartile range? The interquartile range. Well, the interquartile range is the range of the middle 50%. And if you think about this, we just did max minus min to get range. And that's what range is equal to. But the interquartile range, we're going to give a new name to this. We're going to count up one quarter right here and call this Q1. Notice how we've gone through one quarter. When we go all the way over to here, we're going to call this Q3. So that's 3/4 of the data. So the interquartile range, let's write this as a new formula over here. The IQR is equal to Q3 minus Q1. Notice how Q3 is big number, like max is big number, and Q1 is small number, like min is small number. So it's just big number minus small number. You're just saying big number minus small number to figure out their distance, just like the range is big number minus small number to figure out their distance. Like, how far are these numbers apart? All we're doing is finding a range of numbers. New semester, same RotoWave, same huge points. If anyone's in the chat, you got some big points. RotoWave, it's the start. This is the first kind of real office hours. I've already mentioned you like 3 times, RotoWave. I mentioned you during mini term. I should like pulp that video, but I mentioned you because people see the RotoWave level and stuff like that, and they're like, "Who's RotoWave?" Or I'm like, "Let me tell you about RotoWave." But RotoWave, I hope you're doing well, and I hope you swing back by Haslam. I've seen a few people around campus. I said hey to them, but man, it's so good to see you. I really appreciate you swinging by. If anyone's watching this portion of the video, learning about the IQR, RotoWave is one of our Ch1 legends in the chat. And if RotoWave checks their points, RotoWave has some of the highest points in the Ch1 history. So RotoWave is Ch1 legend. No stopping RotoWave right there. Maybe Thanos. Thanos isn't around anymore, though. So the last number we can mark right here is in the middle. I'm a little congested today, RotoWave. Is the median. It's the 50th percentile. And that's got it. That is gonna do the canvas content. It is Q3 minus Q1. It's their distance. Should get a hundo. I thought I missed something. I saw that pink area. I was like, what'd I do? A blank is a group of people or items we want to understand. Well, this isn't what we get our understanding on. It's what we want to understand. That'd be a population of interest. The statistic is what we learn from a sample. A sample is what we get data on. And a parameter is the truth we want to understand about the population. So with the cake example, you take a slice of cake, a sample. You rate the cake, or multiple people do and average it, a statistic. You want to understand all the cake, the population, and how tasty the whole cake is. Or for the town example, you want to understand what the people in the town think of the cake, and what they think of the cake is the parameter of interest. It's some sort of quantity or value of the population that you want to understand. So is the group of items we want to understand is the population. An identifier is a special case categorical variable, and we see that here in the notes. We took a lot of notes on this today. Identifiers are special case categorical variables. And why start of the semester? They are. Quantitative variables must be numeric. True. They must be actual real numbers. You can do math on them. Take the mean of the data. This is a symmetric data set, as in like 25 is right perfectly in the middle. 20 and 30 are equidistant from 25, as is 18 and 32. They are 7 away. So you can do the math. To find the mean, it is the sum of all the observations. Points. And then you divide by the amount. There you go. RotoWave's at Mike, Marshmallow, Grugo, Tiny Brian, Mando, Thanos, Goku. I know who Goku is. Got over like 1 billion points. Over 1 billion points. No one can compete with that. Which crime was the least frequent? It is violent crime. You can see by the smallest slice on the pie chart, a great way to display categorical data. Oh man. I hope. I went from having a like little tickle in my throat on like Tuesday night, and then just congested. Like a little headache, a little congested. Player identifier is identifier. Blank is collected to make inferences on a population of samples collected. Quantitative variables must be numeric. True. 25. Which type of variable is a univariate display of quantitative data? We have the chart for this. Take a picture of this if you're watching this. RotoWave doesn't have to. But univariate quantitative is this region. There's no other variable over there. This is the bivariate region. Up top is the univariate. So histograms, box plots, stem, and leaves, notice how they're blue. These are bivariate quantitative. Scatter plots, time plots are bivariate quantitative. These are bivariate categorical. This is cat quant. If you go across, like you have to crisscross all the way to the side there, like you go here and you do like, okay, the y variable is quantitative. The x variable is categorical, because see over there on the side. And then the spot I'm covering is bivariate categorical. It has a categorical y and a categorical x. And so you can see all the displays at the top right there, the top left of the histogram, box plot, stem and leaf, and dot plot are all univariate quantitative. So right there, that is univariate categorical, univariate quantitative, bivariate categorical, bivariate quantitative. There we go. If you know, you know. Well, might do. It's the start. Oh, we'll do this one right here. We just did a pie chart. You can make a pie chart of your favorite bars and bar chart of your favorite pies. So that's categorical. Pareto is a special case bar chart. We just said bars and pies are categorical, so Pareto is also categorical. You can use the reference sheet up there. Also, you can see the univariate categorical at the top. We don't do logistic in this class, hence why it's crossed out. And no one likes ring charts. Sorry, ring charts. Histograms we just talked about are univariate quantitative. And stem and leaf plots are histograms where you can see the numbers. Also, univariate quantitative right there. Stem and leaf next to dual plot. But that's got it. That's sure, 4 unanswered questions. Well, I might head off right here because it's a little slow week and I'm going to get some work done. Got to reply some emails. Maybe go home, take a little Dayquil or something, and eat some lunch. But swing by with questions. Let me know. We're going to get people on the Discord. We're going to reply some emails. Until then, bye for now, everyone. Bye. Wrong button.
Hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours.
This ends now.
Yeah.